All right, I think we can probably get started. Thank you so much to everybody for joining us for the first of the CLF Summer Series webinars. And I will let Megan Byrne kick it off and then get started.
Yeah, thanks, Michelle. Good morning, everyone. My name is Megan Byrne. I'm the Communications and Engagement Lead with CLF. And I'm super excited to be supporting the CLF Summer Series. Oh, Michelle, do you want to go to the next slide? Yeah, thanks. The CLF Summer Series on the Embodied Carbon Reductions Built Project Case Study Collection that came out earlier this year from CLF. And over the summer, we'll be hosting this webinar as well as another webinar in August, where we'll be highlighting different set of project teams to share about how they approach their embodied carbon reductions and what they learned along the way, with Q&A time at the end to ask about each project and how y'all might be able to take these case studies and implement these reductions and lessons learned into your own work. So the next webinar will be Wednesday, August 6th at 9 a.m. Pacific. And you can follow along on LinkedIn as well, where each week we'll be spotlighting a couple of the individual case studies to dig in a little bit more to how the project teams made their reductions, takeaways, lessons learned, and resources to support your own efforts. So give CLF a follow on LinkedIn if you haven't already. Um, and then another plug for an upcoming webinar, the 2025 CLF North American Material Baselines, which came out this spring. We'll be having a webinar on August 25th at 10 a.m. Pacific. Save the date for that, and I will drop a link to subscribe to the CLF monthly newsletter so that you can stay up to date on when to register and all of the other exciting things that CLF is sending out in monthly newsletters. So yeah, thank you so much for joining. And if y'all have any technical issues throughout the webinar, feel free to ping me or send me an email. I'll drop all these links in my email in the chat so you can get in contact if anything were to come up.
Great, thank you so much, Megan. Hi, everybody. Welcome. My name is Michelle Lambert. I'm the Policy and Engagement Manager at the Carbon Leadership Forum. And in addition to Megan and myself, we're also joined by Sindhu Raju, who's a project assistant at CLF. And we will be giving a brief introduction today and then turning over the stage to the project teams who worked with us on these project case studies. So as Megan mentioned, in April of this year, CLF published a compilation of 13 built project case studies that demonstrate embodied carbon reductions. It was the culmination of about 9 months of work where we identified projects, collected information, did 2 rounds of technical review, had conversations and interviews with the teams, and then ultimately published these relatively concise, data-driven case studies that also tell the story of these projects and of the teams. And you can see on the map here on the right, where all of the yellow icons are the locations of our CLF regional hubs across North America. And then the red pins are the locations of the 13 project case studies that we published. So there really was a correlation between the places where there are really strong communities of embodied carbon advocates and practitioners doing the work to assess and reduce embodied carbon, and projects that have demonstrated real success. So we are really thrilled today to have team members from all of the projects covered in today's webinar. They'll each be sharing their own insights and experiences and their roles on their projects, and in particular, a focus on the process that they undertook to assess embodied carbon and realize reductions in a whole number of different strategies. So I will let each of the presenters briefly introduce themselves when we get to their project. So the agenda for today is that myself and Sindhu will start with a really brief introduction to the goals and the process of publishing these case studies. And then each project team will give a relatively short presentation. And then at the time at the end, we'll have time for a Q&A with everyone. So if you do have questions, you can either put them in the chat as we go. If they're easy enough for presenters to answer in the chat, they can do that. And then otherwise, we can hopefully have some time for a conversation at the end. So just quickly wanted to put out there why CLF undertook this first ever effort from our organization to publish project case studies, and just kind of understand what some of our goals were for doing this. So, we really were seeing a lot of demand from practitioners, from owners for real world examples of projects that had been built and demonstrated embodied carbon reduction. So we really wanted to try to do something to meet that demand that we were hearing. We wanted to create a public database of case studies, so free, accessible to everyone, that highlighted the range of tools and strategies and processes that are being used in practice by architects, engineers, contractors, owners, developers, so that others could see, learn from these low carbon practices and be able to use them and scale them on their own projects. We wanted to be able to then also support this growing community of AEC teams and owners looking for inspiration and strategies to turn to if they were interested and had goals to reduce embodied carbon on their own projects. And finally, we really saw this as an opportunity to strengthen our relationship with all of our CLF regional hubs through the initial outreach for all of the projects, and then in collaboration with publication of these case studies in their regions. So that was sort of the goals for why we kind of wanted to undertake this in the first place. Just really briefly, I thought it might be useful and interesting to describe the process that we undertook to ultimately publish these case studies. So last fall, we put out a call for project submissions over about a 4-week period. There were some minimum project requirements that we had that Sindhu will talk about in a minute. And in that 4-week period, we received 43 submissions from all across North America. So we were really thrilled with the initial response. Received more projects than we had probably anticipated. We then did our first internal review of those 43 projects. I don't have time to really get into the details of our review process, but we did describe that in detail in the publication introduction section. So please check that out if you want to understand more about how we conducted our reviews. Through that, we narrowed down the list by about half, and then reached back out to 24 of those project teams to request their LCA raw data outputs, and then any other details that we needed to confirm about their process and the results that they had reported. We then did a second, even more detailed technical review of that data. We had some back and forth process with the teams, as well as interviews to be able to better capture, like I had mentioned, kind of the story of their process, in addressing embodied carbon and the lessons that they learned in that experience. We then developed our case study templates so that we would have some consistency in the reporting across all of these very different project types and sizes and locations. We worked with the project teams to develop the narratives, collect images, develop the graphics, the reporting graphics. And then in the end, we had 13 really robust project case studies that we were able to publish in this collection. I will say we had many more project submissions that we wish that we could have developed further and added to these case studies. And we were really limited by the time and funding for that process. So we do hope to identify funding in the future and be able to continue to add more projects to this collection. So I will hand it over to Sindhu to talk a little bit about our project selection process and the outcomes.
Thanks, Michelle. So the project teams were asked to meet a few key requirements. The project must be built, completed in 2019 or later, must be located in North America, and must have completed life cycle assessment or used EPD to determine material-specific reductions or other analysis tools to determine the reductions. And the LCA must also demonstrate measurable embodied carbon reductions. The project team's participation were essential, and we prioritize to include variety of project types and variety of embodied carbon reduction strategies. Next. So in addition to the case studies, the introduction section of the case study collection covers key embodied carbon topics like importance of life cycle assessment, commonly used LCA tools, role of baseline and benchmarks. It also explains what biogenic carbon calculation is and why it is separated and reported separately. And it also highlights the limitations that we came across during the project process and provides insights and future improvements. So the case studies were categorized based on 3 project categories. The category 1 included projects that completed whole life cycle assessment, whole building life cycle assessment, covering at least structure and enclosure. The second category included projects that used environmental product declaration to demonstrate material-specific reductions. And the third category, projects used other analysis tools to achieve reductions in interior, infrastructure, or single-family residential. Next. So further, CLF identified 10 embodied carbon reduction strategies, which each project have used several of these in different combinations based on their goal and context. So the number on the left indicates the total number of projects used these particular strategies among these 13 case studies. So the strategies were low carbon concrete, material efficiency in structural design, mass timber, non-structural bio-based materials, adaptive reuse of building, material reused or salvaged material, single-family residential, reductions of material and use of low-carbon finishes in interiors, reuse of interior materials, and MEP systems. I'll pass it back to Michelle to continue introducing the case studies.
Great. Thank you, Sindhu. So as Sindhu, explained, you can see that we really got a very wide range of project strategies and types. Most projects use, more than one strategy. So it was a really exciting sort of cross-section of many different ways that you can address embodied carbon. So let's jump directly into the case studies, and I am going to hand it over to Christopher Nielsen from Brunner Cott to kick us off.
Thanks, Michelle. So my name is Christopher Nielsen. I'm an associate with Brunner Cott. I was the project manager for the Leaky Parati and Seth Frank Lyceum. Michelle, you can go to the next slide. We were asked or invited to work on this project by the college. The project is an adaptive reuse, but it's also predominantly a new building. The image on the right sort of shows the restored house that was on the site at the time. The college didn't know what to do with, but they knew they had a need for housing their Department of History, and in one location as they were sort of scattered about. The house is about 6,000 square feet, but they were looking to build a project of about 20,000 square feet and sharing it with another department along the way. And I think, on this slide kind of shows the entire team. I'm really actually excited that Jacob's on here too, because he really should be credited for this project as well. This is the first project where we were actually asked by the client to consider embodied carbon. We had studied it on a number of projects, either on our own or sort of through the lens of a third-party certification. But Amherst College had just committed to carbon neutrality for their operations by 2030, and they are actually in the process of building a campus-wide ground source heat pump system that's going to power the heating and cooling of all of their campus buildings. So they're really walking the talk. And this was the first capital project that they had embarked upon after making that commitment. And so had decided that while they were getting pretty good at making very low performing buildings from an energy perspective, or highly performing buildings from an energy perspective, they hadn't really tackled what the buildings were made out of at a serious level yet, and asked us to consider that through the design. So next slide. The sort of concept of the building, again, now you can kind of see the magnitude of how much was saved versus how much is new. The red box titled 197, that was the original house. This was house that was actually titled the president's mother's house, and was built right next to the president's house. We made two sort of formal additions, one that was a sort of special space for larger gathering, which is the blue box, as a companion addition to the existing building. And then we built a bar, essentially a bar building along the back, much more conventionally. And because we've done this on a number of projects, we sort of picked and chose which sort of framing systems worked best for each one of those things. But the selections for those structural systems and the envelopes that clad them were always being done through the lens of both performance outright and also for the embodied carbon performance as well. One of the biggest challenges in this project was that because we were meeting a house essentially that had floor to floor of about 9 or 10 feet, the structural systems were actually really tricky to detail. So if you go to the next slide, you can see, yep, here we go. On the right-hand side, this is where we were able to take advantage of doing some double height space and really use mass timber and express it. Mass timber is fantastic from an embodied carbon perspective, but can be very deep structurally. And so we used it in the spaces where we could really accommodate it. On the left-hand side, we used a combination of CLT deck and steel and set a lot of times that steel up into the thickness of that CLT deck so that we can make a space that's still institutional scaled, but can meet floors of the existing building. Next slide. This project, we had sort of learned from some previous projects, to tackle the structural systems as a primary aspect of the project from an embodied carbon's perspective. But because we were really being asked to scrutinize every aspect, we were able to dive into some other areas that we hadn't really spent a lot of time studying. And so this slide is a collaboration between Jacob and ourselves, really looking at the envelope and studying different options for those envelope strategies to try to drive this number down even further. So on the right-hand side is a very conventional steel stud framed wall using a lot of mineral wool. In the middle, we have sort of a combination of wood framed and exterior mineral wool. And then on the left-hand side, a double stud wall fully filled with cellulose. If you click one more time, you'll get sort of the preliminary results that we were able to then use and work with both our client and our client's, frankly, envelope consultant, who was very interested in the option on the right. And we're able to work with them to figure out how can we get to the option all the way on the left and be able to actually accommodate some storage, some carbon storage in the material choices that we have. We had to work through a lot of building science through that too, to make this wall actually durable. But it allowed us to make that case really strong. So next slide. We used a bunch of different tools to do this study. So at the very beginning, we worked with Beam Tool to do overall analysis. We used Tally during the design phases. And then at the end, we were actually able to study the interiors using EC3, really looking at comparatively picking which products we were going to use. We really focused on the A1 to A3, the product stage, because that's what we have found to be the best and highest quality information we have so far. Next slide. And then our results. So like I said, we were asked to consider both operational and embodied carbon on this project. And so we were naturally drawn towards the ILFI zero carbon standard as a potential third party certification process. Ultimately, we didn't certify the project, but it helped us set really good goals for both of those performance metrics. And so you can kind of see the savings that we were able to achieve based off of some baselines. And in this case, based off of the benchmark of the challenge, we were still able to achieve major dramatic reductions from that requirement. Next slide. And so I guess in conclusion, there's sort of a couple of key things. One is that, we've been thankfully able to play in this realm for about a decade now, but we're a heck of a lot better at it than we were 10 years ago when we were just trying to figure out how to use the tools. Tools are also a heck of a lot better, and the libraries are getting much better, in no small part due to organizations like the CLF organizing things like this to share that knowledge. So we're at this tipping point where I think we can actually start to trust the numbers now, which is really, really quite neat. And then I would say the sort of last thing is that this was a really unique situation where we weren't just trying to meet a standard. We were actually being asked by our client directly to study this, which was very, very fortunate for us, but also really pushed us to consider some things that we may not have. But it allowed us to partner with folks like Jacob and our other teammates along the way in order to push ourselves to do better through our design. So thanks. I think that's the last slide.
Great. Thank you so much, Christopher. That was perfect overview. Also perfectly on time. Thank you very much for that. And I will hand it over to Jacob to talk about the project that he submitted.
Thanks so much. Yeah, Christopher, just wonderful to hear you present on that project. It just, yeah, thrilling. And yeah, honored to be able to share some of New Frameworks work. So I work with New Frameworks for design, build, and fabrication cooperative located up in northern Vermont. And we have a small residence, Kaplan Williams residence. Next slide, I'll tell you a little more about it. So this is a small 1-bed, 1-bath ADU, accessory dwelling unit, that is actually located in the backyard of a residence right in the city of Burlington, Vermont. The family that was in this residence needed to expand, couldn't really afford to move to a larger home, and in addition, wasn't really the right call for that building. And so an accessory dwelling unit solution that became available with changes to Burlington zoning policies that allowed ADUs to be permitted in the city of Burlington to increase housing density in residential sections of the city. And so we were really excited to be able to provide a ADU solution for this growing family, or evolving family. And it also marks a new foray for New Frameworks into prefabricated and pre-designed panelized full home construction, which I'll talk a little bit more about. So yeah, this is a wee little 770 square foot, single bed, single bath, very lovely and comfortable ADU. Next, please. So I'll call out some of the particulars around the construction, and then I'll talk a little bit more around the panelization and the business model part of it in just a minute. Compact home is a really big thing. We're really big fans of sufficiency within our company. Often we'll have owners come to us asking to see how much project they can get for their budget. And we typically pivot the conversation to what is the minimum amount of building you need to provide for your programming. And so that was an ethos that guided the designs of our pre-designed homes. And so that feels super relevant in terms of the overall net impact of emissions. Helical piers are a thing that we have really adopted both as a resiliency strategy in our heavily flood-prone regions of Vermont. We're fast approaching, actually we might be on the anniversary of catastrophic floodings for each of the past 2 years. And so we've been leaning into flood resiliency approaches as well as foundation designs that minimize the use of concrete. The panelization work allows us to bring in straw as an insulation material and to work with local wood in a really cost-effective manner. And so that I'll fill out a little more of that story in the migration to panelization in our company, but we're able to use organic straw as an ag residue for the insulation for the majority of the buildings, so wood fiber insulation, and we go pretty far out of our way to source locally milled wood products from sustainably managed forest lands whenever possible. I guess the other thing to name is there is we didn't quantify the emission reductions with MEP, but we went really far out of our way to keep those systems as compact as possible. So between load reduction, which reduces the equipment size and the charge of the heat pump system, as well as the distribution of the refrigerant within the building, and then the distribution of piping within the building, all of that it reveals itself as embodied carbon reductions by virtue of a compact design that also has cost reduction benefits as well. Next, please. Just want to give you a picture of what a straw panel looks like. For all practical purposes, you can just think of a double stud box stuffed with straw. So if that's your like walking around mental model, what we're looking at here is the interior that is ultimately covered in a vapor variable airtight membrane. No one need know there's any straw in the box if that proves more of a liability or a concern rather than an asset. In our case, it's an asset, so it's an effective way to store biogenic carbon in the built environment. So we kind of lean into that while also supporting local organic farms within our supply chain and working with a working landscape conservation model in our rural communities. But there's a picture of a straw panel in case you were confused as to what that is. Next, please. So we stayed within the realm of A1 to A3. Material emissions was our boundary. I'm a co-developer of the Beam tool, and so I use that tool heavily in all of our assessment. And we included, all the things to see here. We won't dwell too much more on that since I'm running a little long on time here. Next slide, please. I guess the thing to name here is that we headed into the design of all 5 of our pre-designed buildings with a goal of being net carbon storing at day 1 of operation. So again, you can look in the report for details around how biogenic carbon was documented within the case studies. And so sort of above the line there, we're looking at about a 50% reduction of baseline without any consideration of biogenic carbon storage. But when we consider just the wood components that we were able to source locally, as well as the straw, it is a net carbon storing building inclusive of the foundation and all other building materials exclusive of MEP and siding. Next, please. So I guess just to wrap up with the lessons learned and highlights here, I won't read through each one of these. I kind of touched upon sort of the more technical details a couple of minutes ago. I think the thing I'll name is that New Frameworks made a really intentional choice a number of years ago, maybe close to 5 years ago, not quite, to pivot from being custom design builders and doing all custom construction to pivoting into being a fully panelization company. And so we found that pivot from custom construction to prefabricated construction, combined with our design team's work, has allowed us to deliver high performance carbon storing building solutions at a much lower cost point with way less friction to way more clients. And so it's been really exciting for us to see how the combination of prefabrication, high performance construction, and local bio-based natural building technologies have all been able to optimize for each of those in these pre-designed and fully panelized homes, such that we're able to meet the demographics of our sort of kind of working class rural communities and using local materials and providing carbon storing buildings. I'll leave it there.
Great, thank you so much. You're all doing a fantastic job of packing so much, really fascinating information on these projects into a short time. So appreciate that very much. So staying on the theme of bio-based materials and straw bale construction, I will hand it over to David Arkin to talk about Ocean Spray townhomes.
All right. Thank you, Michelle. Thank you, everyone, for joining us today. I'm a principal at Arkin Tilt Architects based in the San Francisco Bay Area. And part of our Bay Area CLF chapter actually was with CLF early on as a co-chair of the Renewable Materials Task Force. So early on, CLF had a focus on these carbon storing plant-based materials. Also have served 10 years as the director of the California Straw Building Association, the AIA's 2030 commitment, and represented AIA on the ECHO project. Next. And today, thrilled to talk about a recently completed and occupied project of ours, the Ocean Spray Townhomes in Ashland, Oregon. It's a 2.5-story, 4-unit development. What you might call the missing middle, in that it is that low scale, mid-rise infill housing in a largely residential, single-family residential neighborhood, but adjacent to Southern Oregon University, where there is some student housing in the area, and I think represents, the right scale as well as a number of carbon storing and other features in addition to the story we're about to tell. The project does feature 7.2 kilowatts of photovoltaics, so it is zero operating carbon, and then also has a 10,000 gallon rainwater storage, which the units all use for their toilet flushing. Next, please. So just to highlight some of our embodied carbon efforts, I think most significantly, and Jacob outlined this well with their project, the ability of straw as a plant-based resource to store carbon cannot be understated. We grow enough grain straw worldwide. I think it's 2.16 billion tons, which is enough to not only replace all of our insulation materials, but in doing so, we would offset all of the global transportation emissions. So we're quite excited about this particular resource. On this particular project, we used it as infill insulation, a system we call bales on end between studs. So it has regular 2x6 framing at 24 inches on center. The 3-string rice straw bales stack vertically between those studs and serve as the substrate for a locally sourced clay plaster finish on the interior. But on the exterior, it's simply a weather barrier and lime plaster finish. So the sort of thing that contractors are used to doing, building scientists are standing behind that as a, long lasting, durable exterior finish. We did some other measures in the design of the building, used a raised framed wood floor instead of a concrete slab on grade, even though that would be the typical type of foundation here, again, to minimize the amount of concrete. We tried to keep to a very simple building envelope, and that in turn also lowered our baseline embodied carbon. And I think the most significant story here is perhaps around the concrete, where we work closely with the concrete subcontractor and the local supplier who had never done a low carbon concrete mix. And using some other information from the Portland area and state of Oregon, convinced them to do a sample using a 59% replacement of Portland cement. And in preparing that sample, the concrete subcontractor not only found it more workable, but really became an advocate for these low carbon concrete mixes. So that was an exciting win for the whole team. Next. So our focus was largely in the upfront carbon emissions. We, like the new frameworks project, use the BEAM calculator, that's building emissions accounting for materials. And we find it a very useful tool for this scale of building. And we go, into a project with some understanding of what measures are the most effective, but then, do that measuring once we're in construction documents and can actually make some choices to try to further reduce those emissions. And again, we focused on A1 through A3, but that's where the bulk of the emissions for the entire life of the project take place. Next. So looking at the reductions, and I think there are 2 points to be made here. The first is that our modeled baseline is starting a lot lower than some of the others that we've seen here. And that is, again, due to that envelope efficiency and some of those design measures taken. And then with the lower carbon concrete and some other choices, we're able to achieve an 18% reduction. But when we look to the biogenic storage and start at a average of 200, we're actually looking at an 87% reduction when we account for that biogenic carbon. And then I think the second point here is that these, bio-based resources are storing carbon now, and that's when those emissions are having the greatest impact on our climate. There's a lot of discussion of what happens at end of life, and I think the options of reuse or biochar need to be considered seriously. Next. So just to wrap up with our highlights and lessons learned, I think we found that we could bring this bio-based resource to a multifamily scale. The wall system was embraced by the contractor who had actually never built with straw bale before. Our clients were on board mostly for its thermal performance, but also we're on board with our efforts to reduce embodied carbon in all the different ways, including integration of salvaged wood resources. And I think we're really looking at this as a demonstration to take it to larger scale. Jacob mentioned panelized construction, but I think these hybrid systems like we used here can also have a role in long-term reductions. Thank you.
Great. Thank you so much, David. Really fantastic to hear about this project. Great. Okay, so I am now going to hand it over to Kathy to talk about the project that you see here.
Thanks, Michelle. Hi, everyone. I'm Kathy McMahon from Moriyama Tashima Architects. We're based in Toronto, just north of the border. And I'm a senior associate here, and I was part of the design team for the Ontario Secondary School Teachers Federation headquarters, which is the teachers union building. It was due for replacement. And so they came to us, if we want to jump to the next slide, looking for a mass timber building, which was amazing. They had already been, studying, how best and how sustainable they could pursue a project for their need. And so they came to us based on some experience that we had on fairly large mass timber projects around the city. And so it was great to work with them. This project is about 127,000 square feet. The teachers union being sort of half of the tenants, and then the rest is kind of commercial office space. It was completed last year. The project is close to being certified for LEED Platinum, and throughout the design and construction, it was a balance of low embodied carbon and low operational carbon as well, and always balanced to ensure fiscal responsibility for the union's members. The project has a PV rooftop system, solar panels on the roof, also green roof areas. It has a passive ventilation system and a geothermal system to reduce the energy loads for heating and ventilation. And our sustainability lead Transolar and our mechanical and electrical engineers integral throughout the design process helped us really refine and get to the best low energy and low embodied carbon design through multiple energy models and iterations throughout the whole design process. So it was a great experience for us to kind of work with this great team and really align ourselves with a sustainable project. If we go to the next slide. So our structural engineer had a good level of experience in mass timber buildings in British Columbia on the west coast of Canada. And so at the outset, they advised us the best way to sort of work within the project budget and still have mass timber is to be really efficient with the amount of wood fiber that's used. And that means being very efficient structurally. And so we didn't try and perform any structural gymnastics. We looked at several iterations on bay size and came out with the most efficient bay size for an office building. Another interesting piece was our construction managers, Eastern Construction, who were also great. We worked with them to onboard the the mass timber supplier a year before the rest of the materials were tendered, and that was to allow them to come and help us with design assist, refining all the details, ensure efficiency, ensuring with their system that everything was working, in the field as the structural engineers and designers would intend. And it also, there's a queue sometimes for sort of large orders of mass timber, at least in our area. And so to get in line for the production to arrive on site, because that's a major sort of construction sequencing issue. You want to make sure it comes and is erected quickly. And so for all of those reasons, early award of the mass timber was really valuable. If we want to go to the next slide. And so for the LCA, we used one-click. We ran it from A1 to A5, and it was on the envelope and structure. It was completed post-occupancy, so with the shop drawings and completed building drawings, which was very interesting for us because during the design period, we worked with a group from University of Toronto, and they had done a sort of quick bay study, an embodied carbon bay study during the design process, and it was interesting to see how the full building post-occupancy LCA was kind of telling us different things or matching in some areas. So it was a good process. We also, interesting to note is that we used CLT for the exterior wall backup in some beneath the glazing. And that also helped us to reduce the embodied carbon for, your typical, exterior stud wall framing materials that you might use, which we found to be beneficial. So in terms of the baseline, so the city here in Toronto has a Toronto Green Standard guideline, and it's a tiered standard. So tier 2, the benchmark is 350 kilograms of carbon per meter squared. Tier 3, which is more restrictive, is 250. And this project complied even with the more restrictive at 205 kilograms of global warming, carbon emissions per meter squared. So better than tier 3 by 41%. And then if we include biogenic storage, it's another 140 kilograms of carbon that we would reduce. So we would be down to about 66 per meter squared. One of the sort of lessons learned is that the concrete and the steel were major contributors to the embodied carbon. I'm sure everyone here probably could have anticipated that. Some of the more nuanced outcomes were we had, awnings to reduce solar heat gain. We wanted to provide, a lot of daylight for the building's occupants, reduce lighting loads by providing this daylight during the day, but we also wanted to control heat gain. So the awnings were a way to control that, but the sort of embodied carbon cost for the framing of those awnings was something that we wanted to be mindful of. And going forward, what we would like to do is understand, how much the mechanical units were downsized for the avoided cooling costs and really compare that to, the embodied carbon for the framing of the awnings. So once we get a bit more data, I think, available for the mechanical side in terms of EPDs, I think we're close to being able to sort of run that analysis.
Great. I think that's the last slide. Oh.
Yeah, and just a final note, it was kind of great to work with the clients who were focused on, a number of metrics, but financial responsibility and sustainable responsibility, but also sort of care for the building's occupants. And so, mass timber really helped achieve, all of these metrics and a low embodied carbon and a low operational cost for the users and the owners. So, it was interesting for us to kind of participate in that process. So thank you.
Great. Thank you so much, Kathy. And I will turn it over to our last presenter for today, Tyler Pitt, who is going to talk about the adaptive reuse project that they submitted.
Thanks, Michelle. Hi, everyone. My name is Tyler Pitt. I'm a project architect at VMDO in Charlottesville, Virginia. Apologies if you guys lose me for a second. We're in the middle of what I would describe as a biblical thunderstorm. So I have my phone. Well, we lost power once. We'll hope it stays on for the next 5 minutes. But excited to talk to you guys about Thurston Hall. You can do a slide, please. Thurston is a renovation project of a large residence hall at George Washington University in Washington, D.C. Um, and I think, unlike a lot of the other projects that were presented today, we didn't really have super strong carbon goals, and that, why would we be talking about a project that didn't have super strong carbon goals at the CLF event? What we found that was really exciting and a bit intuitive but still powerful was there was huge benefits to reusing the existing structure. So we'll talk more about that later, but sort of interestingly, the real heart of Thurston is not a carbon story. This was a old 1920s building that had a really terrible dark light well in the center. And this project was really about design and about student experience and carving away this light well to create this beautiful courtyard. It was a really successful project. The client loves it. It's sort of like a flagship building on their campus now. It won 3 AIA national awards. It's LEED Platinum, all that good stuff. So it's really successful in that way. But from a carbon standpoint, we didn't do anything special. Slide, please. So at VMDO, we've been doing a sort of firm-wide study of all of our buildings, looking at embodied carbon. And so Thurston was one of the projects we ran through Tally just to see how are we doing as a firm? What does it look like when we're renovating buildings? So yeah, we ran it through Tally, looking at mostly A1 through A3, but we included some other scope as well. Slide, please. And what we found was really exciting. So this gets a little bit technical based on how you define your baseline. The baseline in this case is what if we built Thurston Hall, 1929 style with brick masonry bearing walls today? That would be your baseline GWP. And so we had like a 29% savings over the baseline. But what was really exciting to us was looking at our new builds. What would it be like if we built Thurston new? There you're looking at about 607 kilograms of carbon per meter squared compared to 272. So by just reusing the structure, we were making really, really huge improvements compared to what the alternative was. So that was super exciting to us. Slide, please. In terms of how we did that, obviously reusing the structure was important, but there was also a lot of additional concrete going into the building to do the structural gymnastics necessary to open it up and to deal with a lot of old conditions that weren't up to current code. So there we used a concrete mix that was about 40% slag. Actually, we're looking at the submittals, it was a little bit better than that, but this was in Washington, D.C., and that's really nothing crazy for D.C. That's a pretty standard mix, something that we always push for on our projects. But nothing super crazy there. We use mineral wool insulation instead of foam, insulating from the interior of the historic building. But then again, pretty standard practice for us. Slide, please. And so what I think is really exciting about this project is it just shows that building reuse really is climate action, and that you can meet your design goals and meet your sustainability goals, and also save on embodied carbon by reusing existing structures. So really for VMDO, I view this as a starting point. This is like how good can we be without really trying? So it's super exciting to see all the other projects and all the great ways that when you are building new, you can reduce carbon through your envelope, through your insulation, et cetera. So I think the next step for us is really taking those lessons, understanding that we really want to advocate for reuse with our clients whenever possible, and then pushing that envelope a little bit. But really excited to be able to dig into this project with CLF and sort of look at work that we had built and evaluate it, and really excited for the future as well. Thank you.
Thank you, Tyler. And I hope this demonstrated to everybody, that reductions and are possible across any scale of project, and so many different strategies and really exciting creative ideas across all these projects. So fantastic job on timing to the presenters. And we have about 10 minutes left for some questions and answers. And you're welcome to either put those in the chat, or if you'd like to just raise your hand and ask your question directly, that would be great. And hope to have a little bit of a conversation about these projects. I will stop sharing so we can see each other. Anyone have the first question they'd like to ask? If not, we do have our own prepared questions, but I just want to make sure, maybe we can kick it off, and then if anyone has a question. So to any of you who want to jump in first, one question is, and I actually feel like Tyler started to address this already in his presentation, but what did you learn from this project related to embodied carbon that you are going to take forward now to your other current projects or your practice? Feel free for anyone to jump in.
Yeah, I can expand a little bit. I think in addition to reusing wherever we can, concrete is super important. And there is a big difference between what you specify and what you actually get on projects. We had specified carbon cure. We had some other technologies in our spec that didn't end up going through in construction. So moving forward, I think we want to be really smart about how we specify low concrete carbon and giving the concrete subcontractor as much flexibility as possible to get to that design without being too restrictive. So I think there's sort of an art to it and something that makes a huge difference overall on your total carbon and something we really want to dig into more.
Yeah, I can jump into, I think one of the things that I learned was a bit about the wood industry in our region. We had initially included FSC certification for all of our wood products. Through digging in with our contractor, it became really clear that in order to get trusses, for example, we were going to harvest wood somewhere in New England. It was going to have to get shipped to Texas to be assembled by a certified manufacturer and then shipped back, which really sort of defeated the purpose of what we were trying to do. And so I think, there's nuances to every industry and every material that I think, the more you do work, the more you kind of learn some of what those nuances are. It doesn't mean to me that we should not be asking for things like FSC certification, because I think that there is a real value to that certification, but it was just an interesting nuance that we learned about that industry. And you really do have to dive in and understand your supply chain, which is not an easy task as an architect.
Yeah, I'd say
please.
One surprise, frankly, but maybe it shouldn't have been a surprise, was through the beam estimator's output, seeing that the metal roof, which is otherwise great at collecting rainwater and very durable, and also the aluminum clad dual glazed windows were among the highest emitters of the materials after we, tried to use better and less wood and better and less concrete and store carbon and straw. These other materials have big impacts. And so I think our next challenge is how do we find better options for those things without sacrificing durability and ending up having to replace those, which then works in the opposite direction.
I'll just chime in really briefly. I want to amplify Christopher's note there around wood supply chains. I learned that very much on the Brunner project, as well as just in our own ongoing practice. It's been interesting moving from being custom home builders to fabricators. The supply chain shifts a bit in terms of the consistency and quantity of materials we're providing. It's no longer on a case-by-case basis. And so it gives us some opportunities, but also some additional challenges in regional wood supply chain development. And yeah, the more you look, the more you see, and the more work there is to do there. But there's also a tremendous amount of opportunity. And so there's a real wood industry and building industry trying to really move towards each other very actively. And so there's some definitely good lessons learned around how we can participate better in that relationship building, that sort of cross-sectoral industry relationship building, which will, I think, benefit all of us working with wood. The other really quick plug I'd say is MEP. I think we're at a point now, and that was mentioned earlier as well, and a couple of folks, we have data now that we can actually start to quantify this, and it's going to change our baselines, it's going to change our quantifications, it's going to reveal some of the values that we knew sort of prescriptively but couldn't actually quantify, and then be able to put numbers to that will help us optimize. And so super excited to see how we can develop better outcomes with better data around these really insignificant components of the building that are not well represented in these case studies yet.
Yeah, that's a great point. I think that, the data and availability of that data is getting better every day. So we'll be able to refine, what we know. And what we could assess. We do have one question from Laura. It is, did any of the measures increase the cost of the project? And if so, how did you convince the client about the extra cost? Anyone have any insights on that?
Might jump in and just kind of note for our project, I think the mass timber structural system was a higher cost than a steel would have been. But because it was sort of ingrained into the project requirements, we made other things fit into the overall budget. So it's not, you just have to understand you have to work within the budget, and then everything is a system. And if one thing costs more, something else has to come down. And so, just kind of big picture, meeting the overall budget is the goal, and each piece can play its part.
Yeah, our project probably had sort of two stories about that. One is very similar, right? The goals were baked in at the beginning. And so when VE was requested, it actually got pulled out of square footage rather than the materials choices because we had made good cases for it. But then we also found some pretty interesting places where we could do carbon storage. It's in these like invisible things, acoustic insulation. Rather than using fiberglass bats, we found a company that made cellulose bats, so that you could just blow cellulose into a wall and then it would fall out if you ever had to renovate anything. These are actual bats. There was a slight increase for that, but again, because with Jacob's help, we were able to show that just the tremendous storage of that one material, and then put it in the context of the project. It was sort of an easy sell for the additional cost for that item. Sort of a mundane product, but a carbon win.
It also seemed, I was reflecting on, these 5 projects all seemed to have an owner that was relatively on board from very early on. And curious if in our last minute, anyone wants to kind of reflect on, that versus other projects that I'm sure you've worked on, where the owner is, needs to be convinced of the benefits.
I guess one thing I'll say about that, in our experience, which is dealing with a wide variety of owners, both in consultancy and our direct work, I don't actually think convincing anyone to spend more money on embodied carbon works. I think people are either bought in around that issue, or they don't see value in it. And I think it's incredibly difficult to change owners' value structures and belief systems in the context of a project. What I will say is there are many opportunities that a lower embodied carbon solution is also a cheaper solution. You're using less materials, right? Or that there's a design change that has a stack of benefits, of which embodied carbon happens to be one. We find it's way more successful for us to sell aesthetics and health, where people tend not to put an ROI on those metrics. And if they are also lower embodied carbon, then it's a win. Finding the multiple attributes within a given strategy and selling the attributes that hold greatest value to the client, if that's cost reduction or health benefits or whatnot, is I think a lot more successful and has a lot less friction and aligns more with the client's existing value structure, and then bring embodied carbon along for the ride than trying to get them to change their belief or value structure, which I just have not really been able to find effective in any of the projects I've worked on.
Yeah, that I think that resonates probably with most. So we are at the hour, and I just want to again express appreciation for all of the project teams who participated and collaborated with CLF on this work, and everyone who attended today to hear about these projects and hopefully take those lessons into your own practice. So thank you all, and hope to see you on our second August webinar. Bye-bye.
Thanks, everyone.
Thank you.
Thank you.